Okay, final lesson of Unit 2, 2-7. It's the only day, so there's no day 2. So here we go. Make sure you're going back and looking at your other stuff, perhaps, because you got a big old test over Unit 2 coming. And Unit 2 is a lot of information. But let's talk about 2-7 right now. Starts out pretty simple, but there are some story problems coming in section 2-7 where you need to understand the difference, kind of a sweeping generalization between a line that has positive slope and a line that has negative slope. So you're going to have to interpret some graphs where you have one or the other, negative slope or positive slope. So let's just take a look at this and say, okay, y equals 2x plus 2. If we were to actually graph that, my y-intercept is 2, then I'd go up 2 from there, right 1. Now, there's the line. Now, if I was thinking left to right, this was an escalator or some stairs or something like that, would I have a positive? Would I be going up or down? Well, left to right, I'd be climbing. So, a positive slope is a climb. Okay? Well, I think you can figure out the opposite. But let's take a look. Y-intercept is 2, so same y-intercept. But then if I went down 2 and right 1 right here, and I kept the same concept, and I'm walking or traveling along that line left to right, notice I'd be going downhill. That little simple truth is going to be very significant on a couple story problems coming up where you have to get a visual image of what the linear function looks like, okay? Keep that in mind. Negative slope, downhill, positive slope, uphill. Keep that in mind as we go through this pre-lesson and the sample problems. You'll hear me refer to this a few times, and that's the reason why. I already know it's going to be like this. I think that was negative slope from your perspective, or this, positive slope from your perspective. Now, let's move on to this. This doesn't ask what are the solutions. This says how many solutions. So remember, if we have a parabola and a line, it could be like this, where there are no solutions. It could be like this, where it touches it exactly in one place, or it could be like this, where we have two solutions. So those are our three possibilities. So now they're expecting us to be able to graph this. So let's give it a shot. So y equal x squared, we know is our generic. We've dealt with that a lot. How about y equals 2x? Well, technically there's a plus 0 there. So that's our y-intercept. So we know we have at least 1. But if we go up 2, 1, 2, right 1, my drawing doesn't need to be perfect. I can see there's going to be 2 places. So this would have 2 solutions. Now the question asks, if I took that y equals 2x and I just took it and I added a different y-intercept, what would happen? Well, if I took a look at this one, y equals x squared looks like this. Y equals 2x minus 3, 1, 2, 3. There's my y-intercept. Up 2, right 1. As you can see, this is a representation of there are these 0 solutions. And I just made this one up, so I really don't know what's going to happen. But if I took my y equals x squared, I know what that looks like. And I graph this, 4. 1, 2, 3, 4. There's my y-intercept. Down 1, right 2-ish. If this kept going up like this, and this kept going up like this, and I drew a line in, you can see we'd also have 2 for this one. So they just want to kind of give you the idea. Now these are just kind of straightforward graphing problems, but now we're going to move into problems that actually make us interpret this information and make sense of it with some real life applications. Pause it a second. Okay, so Now they're going to get a little bit more specific. They don't want to know, okay, how many solutions are there, 0, 1, or 2. They want you to find the exact solution of where these intersect. This is my parabola. This is my line linear equation. So we know there's 3 possibilities, but they're asking us, hey, go for it, solve it. Yes, you could take these into decimals and then drag your cursor over the 2 spots or the 1 spot. If there's 0, you'll just see it. But this is for the portion of tests where you don't have access to your calculator, graphic calculator, or decimal. So what are you going to do? Well, I see that y equals this stuff. That is a classic knee-jerk, hey, I think substitution is going to work because I can put all of this in for y right here. Now the negative you got to be careful with because this is 2x minus y, which is all of this, so I have to make sure to subtract it. And by inserting my parentheses, I'm making sure I subtract all of y. So without those parentheses, I'm in trouble. So this, if I distribute, I get 2x minus 3x squared minus 3x plus 5 equals 3. Now I can see this is a trinomial, so I'm going to just set it equal to 0, rearrange my terms. Negative 3x squared, and then here and here I've got minus x, and then plus 2 equals 0. Now I could multiply this by a negative 1, which I think I'm going to do, because I can see that I could factor this. So yes, before even multiplying it by negative 1, you could stuff this all into quadratic formula if that's what you want to do, but I got a hunch this is going to be factorable. So if I multiply all that by negative 1, it'll just make factoring a little bit easier. And then I say, hey, let's try this. So I'm going to multiply these outside terms because this is not a 1. I get negative 6. 2 factors of negative 6 that add up to a 1. That'd be 3 and negative 2. Remember, if we have a positive and a negative, when we rewrite these, it's better to write the negative 1 first. I'll tell you why in a second. Okay, because when I insert these parentheses here, notice I have a plus in there. If I would have flipped these around, I would have had a negative. It would have made the problem slightly more difficult. Now I'm kind of running out of space here, I see, but I'm going to take an x out. 3x minus 2. I have to take something out. I'm going to have to take a 1 out. 3x minus 2. And then I'm going to write it up here, up higher. So I get 3x minus 2. And then x plus 1. I can just look at this one and go, aha, x equals negative 1. This one, if I apply my trick, what's the opposite of negative 2? 2. And then divide by that, 3. All right, so there's my 2 x's. Now, did I solve the system yet? No, because they want the actual coordinate points. So what I'm going to do is I'm going to find my y's. Now, I'm going to put this in here and here, and I'll be able to find what y is. So I get 3 times negative 1 squared plus 3 times negative 1 minus 5. That's 1 times 3, which is 3. That's 3 times negative 1, which is negative 3, minus 5. That's negative 8 plus 3 is negative 5. So it'd be negative 1, negative 5. Now plugging in 2/3, maybe I'd prefer, rather than throwing it all into this junk, I can throw it here, and my life will be a little simpler. So I'm going to go 2 times my x, which is 2/3, minus y equals 3. Do this. So this is 4/3 minus y equals 3. I'm going to subtract 4/3, subtract 4/3. I know this is 9/3. 3 is the same thing as 9/3. So these cancel. Negative y equals 9/3 minus 4/3 is 5/3. If I multiply that by negative 1, I get y is negative 5/3. So that would be my other answer. 2/3 negative 5/3. Okay, yeah. So that's what you're going to have the opportunity. I'll call it an opportunity solve a few of these on your homework, and substitution is going to be your go-to, your best bet, okay? Now, quick review of Pythagorean theorem. Let me clean this board up, okay? So we got a squared plus b squared equals c squared. The point I want to make is c is always, always, always your hypotenuse. A and b can be switched, doesn't matter. So if I was to take this and figure out this one or this one, it'd go a squared plus b squared equals c squared. So that'd be 9 plus 4, which is 13. Bada boom, bada bing. Do we have to do the right thing? Not in this case, because it's going to be a positive distance. Now, what if this was the case? Well, this is my C. So I know this is my A or my B, but if this is A, this is B. So I'd have to go A squared plus B squared equals C squared, and then solve it from there. Running out of time, so I'm not going to show my work on that one. Okay, going to try to squeeze this in. Example, what is it? Example 3 from page 118, okay? Basic idea, you got this hill right here represented by this equation. You've got a ball thrown right here represented by that equation. You've got a person and a dog, and they're throwing the ball to a dog, and the dog's got to run up this hill. So a couple questions. How far does the ball travel horizontally? The horizontal distance is my x. That's the clue. Find x. Well, if I say, hey, y equals this stuff and y equals this stuff, this is basic substitution, where I set them both equal to each other. Now I'm going to show you some math, but I'm going to hit pause here because I'm running out of time. I'm going to multiply both sides by 10. You can see it's just begging me to get rid of those decimals. Okay? And now, multiply by 10, I can see that I'm going to divide by 5, but you know what? I like this to be positive, so I'm going to divide by negative 5. So it's going to be x squared minus 12x equals negative 1x. Now if I add x here and add x here, I'm going to get x squared minus 11x equals 0. If I take an x out, x minus 11 equals 0, so that would be 0 seconds, or 0 distance, sorry about seconds. So that's right here. But the other thing is, after 11 seconds, excuse me, I keep going to seconds, but after 11 feet, that's here. It could be meters, but that's the horizontal distance right here. That is how far the ball travels horizontally. Okay, so the final question, see, this is 11 feet horizontally. So I'm going to get rid of this 10, get rid of this 5, and I'm going to write an 11 right here. I know that's 11. Now the question is how far must Leica run up the hill? They're asking for this distance. Now the reason for the Pythagorean theorem review is, if I knew the height at this moment, that would be great. Well, if this is 11, and I plugged it in here, I'd get 0.5 times 11, which is just 5.5 feet. So that's 5.5 feet. Now they're asking for this, the distance. So if I plug that into Pythagorean theorem, I'd get a squared plus b squared equals c squared. Let me check my time. Okay, I think I can do this. I got about a minute left. So you can see I squared this, so I'm going to add these together. 151.25 equals c squared. Take the square root of both sides, and now I've got to take the square root of 151. So here we go. 51.25. That's approximately 12.3 feet that old rover or Leica had to run up the hill. Now if they asked how high was the dog above the ground, 5.5 feet. So different ways they can ask you questions. So there's the pre-lesson. More sample problems coming, so make sure to watch the example video.